Everything you picture when you hear the word dinosaur, the scaly green giant, the cold-blooded monster, the slow lumbering predator, is wrong. Not slightly wrong, catastrophically wrong. A velociraptor was roughly the size of a turkey, and it had feathers, vivid, colorful feathers, possibly used to attract mates the way a peacock does today. A Tyrannosaurus rex could not outrun a jogger. Not a sprinter, a jogger. And by the time we reach number 1 on this list, a discovery so unsettling that it divided the scientific community for nearly 2 decades, your understanding of what dinosaurs actually were will be permanently, irreversibly rewritten. Let's go. Number 13. We're starting with something that'll raise an eyebrow and possibly make you feel embarrassed for every museum you've ever visited. Every blockbuster film, every textbook illustration, every theme park model shows the same thing: exposed teeth. Rows of jagged, gleaming fangs. The image is iconic. It feels primal, terrifying, correct. It almost certainly isn't. A 2023 study led by paleontologist Mark Witten analyzed enamel wear patterns on fossilized dinosaur teeth, and the evidence pointed overwhelmingly to one conclusion: theropod dinosaurs, including T-Rex, had lips. Fleshy, scaly lips that covered their teeth completely when their mouths were closed. Think of a Komodo dragon today. Its teeth are fully hidden behind lips. The exposed tooth look belongs to crocodiles, animals with a completely different jaw structure. Dinosaurs were almost certainly much closer to the Komodo end of the spectrum. When Witten's team published their findings in Science, the reaction from the public was immediate: disbelief, then laughter, then a slow, creeping realization that the monster in every nightmare had been misdrawn for over a century. Every museum exhibit, every film prop, every children's book illustration produced in the last 100 years now requires revision. That's thousands of reconstructions across dozens of countries, all showing the wrong face. Turns out, the most terrifying grin in natural history was hidden behind lips the whole time. Number 12. Challenges something you learned in elementary school and probably never questioned again. Dinosaurs were reptiles. Reptiles are cold-blooded. Cold-blooded animals depend on external heat to function. This felt like settled science, the kind of fact you'd use to win an argument at a dinner table. It's wrong. A landmark 2014 study published in Science analyzed the chemical composition of fossilized dinosaur eggshells and bone tissue across 14 species. What researchers found was a metabolic rate sitting squarely between cold-blooded reptiles and warm-blooded mammals. Dinosaurs were mesotherms, a category of animal that doesn't cleanly belong to either box humans invented for them. Imagine your body running at half speed in winter, but accelerating to full capacity in summer. That's closer to what many dinosaurs experienced: internal temperature regulation that flexed with environment and activity. Number 11. We already know T-Rex had lips. What this entry reveals is what those lips could actually do, and it makes the animal simultaneously more terrifying and more delicate. You picture T-Rex as a blunt instrument, a biological wrecking ball, an animal that existed solely to crush and consume. Subtlety was not part of the vocabulary. The snout of a T-Rex contained a dense network of foramina, small holes in the bone where nerves pass through to the skin. This same pattern appears in modern crocodilians, where it enables extraordinary tactile sensitivity. A crocodile can detect the ripple of a single raindrop on water. T-Rex likely had similar sensory capability in its face. That means the animal that could crush a car with its jaw could also, potentially, handle fragile objects, eggs, offspring, food, with a level of precision that scientists are still processing. Picture a construction crane that can thread a needle. This single finding reshapes how we model T-Rex parenting behavior. If the animal could feel delicately, it may have engaged in nest care and physical contact with its young in ways previously dismissed as impossible for an animal of its size. Turns out, the most powerful predator that ever walked the earth also had one of the most sensitive faces. Number 10. Things are getting stranger. This one will make you question every roar you've ever heard in a film, because those roars almost certainly never happened. The sound of a dinosaur is one of cinema's great achievements. Deep, resonant, chest-rattling. The roar of the T-Rex in Jurassic Park remains one of the most recognized sounds in film history. Your brain has heard it so many times it feels factual. Birds are the living descendants of theropod dinosaurs, and birds, with extremely few exceptions, do not roar. They call, they sing, they click. More importantly, paleontologist Julia Clark's research in 2016 revealed that the larynx structure required for open-mouth roaring likely did not exist in non-avian dinosaurs. Instead, they may have communicated like ostriches and emus do today. Closed-mouth vocalizations. Low-frequency booms produced by inflating throat pouches traveling through the ground as much as through the air. If dinosaurs produced infrasound, frequencies below human hearing, they could have communicated across distances of several kilometers without us ever being able to detect it in the fossil record. Turns out, the most iconic sound in movie history was invented entirely by human imagination. Number 9 is quieter than the rest, and somehow that makes it more unsettling. You picture a sleeping dinosaur the way you'd picture a sleeping crocodile. Flat, sprawled, motionless. An animal in the off position. Cold, dormant, alien. In 2004, a remarkably preserved Meilong, a small troodontid dinosaur from China, was discovered in a posture that stopped researchers cold. Its head was tucked under its forelimb. Its legs were folded beneath its body. It had died, apparently peacefully, in the exact sleeping position of a modern bird. This wasn't a coincidence. This was a behavior. The same way a duck tucks its bill under its wing, this dinosaur, 125 million years ago, tucked its snout beneath its arm. The continuity between that fossil and the pigeon on your windowsill is direct, unbroken, and deeply strange to sit with. The specimen's name, Meilong, translates from Mandarin as soundly sleeping dragon, named specifically for the position in which it died. The discovery pushed the origin of bird-like sleeping behavior back by at least 125 million years. Behavioral traits we consider distinctly avian were already present in non-avian dinosaurs, suggesting the transition between dinosaur and bird was not a revolution, but a slow, continuous evolution. Turns out, the dragon that rules your dreams also slept like the bird outside your window. Number 8 is about time. Growth ring analysis. The same technique used to age a tree by counting its rings, applied to sauropod longbones, revealed something that reframes the entire life history of Earth's largest animals. Patagotitan majorum, the largest dinosaur ever discovered, would have required approximately 45 years to reach its full adult weight of 70 metric tons. That's 70,000 kilograms, the equivalent of 10 adult African elephants standing on a scale together. For 4.5 decades, this animal did nothing but eat, grow, and survive. The sheer metabolic demand of that growth curve is almost impossible to model. Researchers estimate Patagotitan consumed hundreds of kilograms of plant matter daily during peak growth phases. The Patagotitan fossils, discovered in Argentina in 2012 by a farm worker who stumbled on a bone protruding from the ground, took a team of paleontologists 4 years to fully excavate. An animal with a 45-year juvenile phase implies extraordinary environmental stability. These creatures could only evolve in a world where food was reliably abundant across half a century. Turns out, the largest creature that ever walked the earth spent most of its life just becoming itself. Number 7. We're entering seriously unsettling territory now. This one is not comfortable. It shouldn't be. Predators kill other species. That's the basic contract of the food chain. Predator and prey occupying separate rungs. Even in the most brutal ecosystems, the idea of a species systematically feeding on itself feels like a violation of something fundamental. In 2010, paleontologist Nicholas Longrich published a study in PLOS One analyzing Tyrannosaurus rex bones recovered in Montana. The bones showed deep V-shaped cut marks, the kind left by teeth stripping meat from bone. The teeth that left those marks belonged to other T-Rex individuals. This wasn't accidental. The marks appeared on multiple bones from multiple individuals in patterns consistent with deliberate defleshing. T-Rex ate T-Rex, possibly as a regular behavior, not a last resort response to starvation. Longrich's analysis identified 4 separate T-Rex individuals whose bones showed signs of cannibalism. Cannibalism as a behavioral strategy has significant implications for population dynamics. If T-Rex consumed its own dead, it may have been exploiting the most calorie-dense food source available in its environment. Some researchers now believe this was an adaptive behavior during periods of prey scarcity, which rewrites how we model the apex predator's ecological role. Turns out, the king of the dinosaurs had no loyalty to its own crown. Number 6 isn't a fact about the past, it's a fact about right now, this moment, outside your window. The story of the dinosaurs ends with an asteroid. Approximately 10,000 species of dinosaur are alive today. We call them birds. The evolutionary lineage from small feathered theropods, animals like Anchiornis and Archaeopteryx, runs unbroken to the sparrow on your garden fence. Birds are not dinosaur descendants. Biologically, taxonomically, they are dinosaurs. A chicken in a supermarket is more dinosaur than any museum fossil. The asteroid didn't kill dinosaurs, it killed the non-avian dinosaurs. The lineage survived, diversified, and currently occupies every continent on Earth, including Antarctica. There are more dinosaur species alive today than at any point during the Mesozoic era. When Thomas Henry Huxley first proposed the bird-dinosaur connection in 1868, he was widely dismissed. It took over a century and the discovery of feathered Chinese fossils in the 1990s to force the scientific establishment to accept what he had already understood. With over 10,000 living species distributed across every ecosystem on the planet, the dinosaur lineage is one of the most successful in vertebrate history. The extinction narrative taught in schools is not just incomplete, it's the opposite of true. Turns out, dinosaurs didn't go extinct, they just learned to fly. Number 5. Dinosaurs ruled the day. That's the implicit assumption. Giant reptiles baking in Cretaceous sunlight, heat amplifying their dominance. The night belonged to small, trembling mammals, waiting for dawn in hidden burrows. A 2011 study published in Science examined the sclerotic ring, a ring of tiny bones inside the eye that determines pupil shape and controls light intake across 164 fossil species. The results were unambiguous. Large-eyed theropods like Velociraptor had eyes structurally identical to modern nocturnal predators. They hunted in the dark. Your eye, in darkness, dilates to gather more light. A nocturnal velociraptor had eyes optimized to do the same thing, but at a scale and efficiency that dwarfs human night vision. This animal didn't just tolerate the dark, it owned it. Lead researcher Lars Schmitz compared the fossil data against 164 living species and found that the correlation between eye structure and activity pattern held with over 90% accuracy, making this one of the most statistically robust behavioral inferences in all of paleontology. If key predator species operated nocturnally, the entire ecosystem model for the Mesozoic changes. The small mammals hiding in burrows weren't just avoiding dinosaurs during the day, they may have shared the night with some of the most efficient predators on the planet. Turns out, the animals cowering in the dark were sharing it with something that could see them perfectly. Number 4. Dismantles the throne. The king you've been told about was never actually the largest. Tyrannosaurus rex. The name itself translates to Tyrant Lizard King. It anchors every conversation about prehistoric predators. It wins every imaginary battle. It is the default answer to largest carnivorous dinosaur in classrooms around the world. It's the wrong answer. Spinosaurus aegyptiacus, a semi-aquatic predator that stalked the rivers of North Africa during the Cretaceous, measured up to 15 meters in length and potentially exceeded 20 metric tons. T-Rex reached approximately 12 meters. Spinosaurus didn't just exceed T-Rex in size, it operated in a completely different ecological space, using its elongated crocodilian snout and dense bones to hunt fish in deep water. Picture a predator the length of a school bus that could swim. That animal existed. It walked on land and entered rivers the way a heron wades into a stream, except it weighed more than 3 adult hippos. The original Spinosaurus fossils were discovered in Egypt in 1912 by German paleontologist Ernst Stromer, and then destroyed by Allied bombing in Munich in 1944. The species had to be reconstructed almost entirely from scratch when new fossils emerged in Morocco in 2014. Spinosaurus's semi-aquatic lifestyle means it occupied a predator niche previously unrecognized in large theropods. Its existence proves that the largest carnivores in history didn't just conquer land, they conquered water too. Turns out, the king of the predators was hiding in a river the whole time. Number 3. This is where the story gets genuinely disturbing. Not because of violence, but because of tenderness. And because of what that tenderness implies. Dinosaurs laid eggs and left. That's the cold-blooded reptile model. Deposit the eggs, walk away, let nature handle the rest. Parental investment was a mammalian invention. Dinosaurs were too primitive, too instinct-driven, too distant from us for anything resembling care. In 2004, a fossil of Psittapodi osmolskae, an oviraptorid dinosaur, was found in Mongolia in a posture that has no precedent in the reptile fossil record. The adult had its arms extended over a clutch of eggs, its body positioned to shelter them. It had died in that position, preserved by a sudden sandstorm. It died protecting its nest. Subsequent discoveries found multiple oviraptorid specimens in identical brooding postures. The behavior wasn't an accident or a coincidence. These animals sat on their nests, actively, deliberately, at the cost of their own lives, the way a hen sits on her eggs today. Paleontologist Mark Norell of the American Museum of Natural History, who led the analysis of the Mongolian specimens, described the moment of recognition as one of the most startling things he had seen in 30 years of fieldwork. If brooding behavior was present in oviraptorids, a group that split from the main theropod lineage over 75 million years ago, it likely evolved far earlier than previously thought. Parental care, one of the behaviors we consider most essentially human, may have deep roots in the Mesozoic. Turns out, the instinct to shelter your young from the storm is older than we ever imagined. Number 2. Brace yourself. What comes next rewrites the physics of the most famous predator in history. T-Rex as apex predator implies physical superiority in every dimension. Speed, agility, power, the complete package. An animal that could track, pursue, corner, and overwhelm anything in its environment. A 2021 biomechanical analysis published in PLOS One calculated T-Rex's turning radius based on muscle mass distribution, leg length, and body weight. The result? At full speed, a T-Rex required approximately 2 full seconds to turn 45 degrees. 2 seconds. In predator terms, that's an eternity. A horse can change direction in under half a second. A modern athlete can pivot in less than 1. And yet, T-Rex dominated its environment for over 2 million years, the longest reign of any large theropod in the fossil record. It didn't need agility. Its ecosystem didn't require it. The prey animals it hunted were slower, larger, and even less maneuverable. T-Rex was the fastest thing in a landscape of things slower than itself. This finding changes how we model predator-prey dynamics across the entire late Cretaceous. The apex predator wasn't the most agile animal in its environment. It was the most optimally suited. Evolution selected for power, reach, and endurance over speed and agility. That's a fundamentally different kind of dominance than the one we've been picturing. Turns out, the Tyrant didn't need to be fast. It just needed everything else to be slower. This is it. Number 1. Not a discovery. The absence of one. Science gives us certainty. Fossils give us answers. We expect 66 million years of rock and pressure to eventually yield the full picture. The tools are improving. Somewhere in the data, the truth exists. Melanosomes, the microscopic structures that determine color, occasionally survive fossilization. Researchers use them to reconstruct Microraptor, iridescent black, like a crow. Sinosauropteryx, ginger and white-banded tail. But for large theropods, T-Rex, Spinosaurus, Giganotosaurus, the skin impressions contain no preserved melanosomes. None. We have texture. We have scale patterns. We do not know what color they were. We may never know. Every image of a T-Rex you've ever seen, green, brown, gray, was a guess. A creative decision made with no data to constrain it. The most studied animal in the history of paleontology walks through our imaginations in a color we invented for it. Paleontologist Jacob Vinther put it plainly. The skin may simply be too degraded, too compressed by geological time to preserve what carries color. The answer may be permanently beyond our reach. After 150 years of study, we cannot tell you what color it was. Every museum diorama, every film frame, beautiful fiction built around real bones. Turns out, the animal we know best is the one whose face we've been painting from our own imagination. You came in with a dinosaur. You're leaving with something far more complicated, far more alive, and far more honest. An animal that had lips and possibly feathers, that hunted in darkness and brooded over its eggs, that communicated in frequencies we can't hear and died in colors we can't see, that survived an asteroid and currently sits outside your window, singing. The monster of your childhood was always a projection. What the fossil record actually offers is stranger, richer, and more connected to the living world than any film has managed to capture. Here's your question for the comments. If we discovered tomorrow, definitively, that T-Rex was bright pink, would that change how you feel about it? Or has the idea of it already become too fixed to update? If this channel makes you see the world differently, not just learn facts, but actually shift the lens through which you understand deep time, evolution, and science, subscribe. Because next time, we're going somewhere even older. The facts about human evolution that paleoanthropologists have quietly revised in the last 10 years. And some of them will bother you more than anything on this list.